Graph linear functions in standard and absolute value functions. Graph linear functions in standard form. Joke of the day. As you can see, by late next month, you'll have 4 dozen husbands. Better get a book grade on wedding cake. Standard form. It's a linear equation. Equation is ax plus by equals c. A and b are not zeros. A, b, and c are integers. You can graph an equation in standard form by identifying and plotting x and y intercepts, or graph standard form by converting it to slope-intercept form. Y equals mx plus b. X-intercept is z, x-coordinate of a point where a graph intersects the x-axis. Here are the steps using standard form to graph an equation. 1. Write an equation in standard form, y equals ax plus by equals c. 2. Find x-intercept by letting y equals 0. 3. Find y-intercept by letting x equals 0. 4. Draw a line through the 2 points. Example 1, 10x plus 4y equals 20. Graph the equation. So our first step is to write equation in standard form, y equals ax plus by equals c. Luckily, our equation is already in standard form. So the second step, we have to identify x-intercept. Let y equals 0. So what we're going to have to do is substitute y to 0. So it will be 10x plus 4, 0 equals 20. And basically, it will be 10x equals 20. And x would be 2. So this is one of our points, 2, 0. Our third step is to identify y-intercept. So let x equal 0. So now we have to substitute x to 0. So it'll be 10, 0 plus 4y equals 20. So it'll be 4y equals 20. And y would be 5. So this is our second point in the graph. And our last step is to graph and then draw lines through the 2 points. Okay, so our final step is to basically draw the 2 points in our graph. Our x-intercept is 2, so we're going to have to plot that in our x-axis. So 1, 2. And then our y-intercept is 5, so we're going to have to plot that in our y-axis. So 1, 2, 3, 4, 5. And so what we're going to do is just to connect the points together. So basically, this is our graph. Example 2, 2x minus 3y plus 6 equals 0. Graph the equation. So what we're going to have to do first is write the equation in standard form. So it would be 2x minus 3y plus 6 equals 0. And then you're going to have to minus 6 to both sides of the equation. So it will be 2x minus 3y equals to negative 6. So this is in standard form already. So now what we have to do is identify x-intercept. So let y equal 0. So substitute y to 0. So 2x minus 3 times 0 equals negative 6. So x would be negative 3. So this is one of our points. And now we're going to substitute x to 0 to get our y-intercept. So 2 times 0 minus 3y equals negative 6. Negative 3y equals to negative 6. So y would be 2. So our y-intercept would be 0, 2. So these are the 2 points that are going to plot in our graph. Okay, all we need to do is connect and plot the points in our graph. So our x-intercept is negative 3. So we're going to plot it in our x-axis. So 1, 2, 3. Negative 3 is here. And then our y-intercept is 2. So we're going to plot the y-intercept in our y-axis. So 1, 2. And now all we need to do is just connect the points. And then that's our equation.
Graphing absolute value functions. Pun of the day. Absolute values won't put up with negativity. Put any values but 0 behind bars and the results will always be absolutely positive. You can graph an absolute value functions using the vertex and symmetry. Then comparing it to the parent graph, y absolute value of x.
Here you go.
Absolute value of a real number x is defined as absolute value of x equals x if x is positive, 0 if x equals 0, negative x if x is negative. X equals absolute value of x is the parent for the family of all absolute value functions. Graph for f of x equals absolute value of x is V-shaped and is symmetric about y-axis. This means that every point x and y on the graph, negative x and y, will also be on the graph. Vertex highest or lowest point on the graph of an absolute value function. For example, here is the vertex and this is the lowest point of the graph. Transformation changes the graph size, shape, orientation, or position. Translation shifts the graph horizontally or vertically, but doesn't change shape, size, or orientation. Graph of y equals absolute value of minus h plus k is the graph of y equals absolute value of x. Translated h units horizontally and k units vertically. Vertex of y equals absolute value of x minus h plus k is h and k. Coefficient a controls the orientation and shape of the graph. For example, the parent graph right here shows the absolute value of x, and the absolute value right here is y equals absolute value of x minus h plus k. Absolute value of a greater than 1, graph is vertically stretched, narrower than graph of y equals absolute value of x. Absolute value of a less than 1, vertically shrunk, wider than y equals absolute value of x. Example 1 shows y equals absolute value of x plus 4 minus 2. Compare graph with graph of y equals absolute value of x. Here shows y equals absolute value of x. Step 1, identify and plot vertex. Right here shows negative 4 as h, negative 2 as k. And right now I'm plotting the vertex. Calculate y values and list in table. As you can see, we chose these as our x values because it's closer to the vertex. Okay, here shows the x values and you plug it into the equation. For example, y equals absolute value of negative 6 plus 4 minus 2. So negative 6 plus 4 is negative 2 minus 2. The absolute value of negative 2 is just positive 2. So 2 minus 2 equals 0. Here's the other x values that we plotted. So here's the table that we finished, and now we're just going to plot and connect the points. So 1, 2, 3, 4, 5, 6, 6 and 0, and negative 5, so 1, 2, 3, 4, 5, and negative 1, and negative 3, so 1, 2, 1, 2, 3, 3 and negative 3 and negative 1, and negative 2 and 0, so negative 2 and 0. And now we connect and plot the points. Oh, I messed up. Compare with y equals absolute value of x. Graph of y equals absolute value of x plus 4 minus 2 is the graph of y equals absolute value of x. Translated down 2 units and left 4 units. So 2 units, 1, 2, 1, 2, 3, 4.